Alright guys, welcome to the stream. I think I'm online. I'm just checking off screen over here. Looks like I'm good to go. We're gonna get the show on the road. It's not gonna take too long. Just gonna do a little bit of housekeeping. Um, just off screen now, so just bear with me guys. I need to share the link. Just gonna quickly attend to that off screen. How have you guys been since the last video? It has been about 2 weeks, so I know I'm a little behind schedule, but it should be a great workshop. I got some very interesting content planned for today's workshop, and there's my video, so I'm gonna go ahead and just share the link on my Instagram. My Instagram is Williams_Teddy-Jimoh for those of you who may want to follow me. I do post snippets of my coding endeavors. And if for whatever reason, as I always say, the stream cuts out, just do bear with me because my setup isn't the most beefy, I could say. And as a result, sometimes like things cut out and stuff. So let me share this link. All right, I think we're about good to go. Okay, so my name is Will. I'm a .NET specialist in that, I specialize in writing .NET stack software, C#, UWP, WPF, Windows Forms applications, anything from there. On the web side of things, I kind of dabble in ASP.NET MVC Core, and on the database side, SQL, I always struggle with this one, interrupting with .NET applications. So anyway, what we're going to do in this particular episode of this workshop is that I want to walk through with you guys in a rather chilled manner. It's a sequel to the last entry of 2D video game development using C#. In this particular case, for the front-end framework, what we're doing is that we're using the Universal Windows Platform target, which is quite a modern target. Even though it has been succeeded by the .NET MAUI platform, I still find this a very relevant target, and you can still upload applications up to the Microsoft Store for Windows 10 and 11. So it's very relevant, I would say. And let's do a little bit of a recap. So where we left off from the previous episode, I do recommend that you watch the last live stream in this entry to make any sense of this. This really does jump into the mid to the deep end. If you don't know C# or you're just getting to grips, this might be a little bit ahead of the curve, so you can watch my C# fundamentals video, which is on my channel. Otherwise, if you're familiar with C#, you know what you're doing, this is going to be a great video if you're interested in the topic. So anyway, what's going on here is I'm going to just literally take off from where I left, and then we're going to see what has happened off screen, and we're going to continue on our agenda here on the right hand side. So we made a class called Load Animated Resources, and because we're using the Win2D library, it's a graphics library provided by Microsoft. Let me see if I can get it up on the screen. So Win2D is an easy-to-use Windows runtime API for immediate mode 2D graphics rendering with GPU acceleration. It is actually available for C#, C++, and VB, targeting the UWP platform, but it also targets the WinUI platform, if I'm not mistaken, there as well. But we're focusing on the UWP platform. Let me just see if I can go to the features tab. Yeah, and you can find a lot of resources here. Basically everything to do with Win2D you'll find here. I've used this quite extensively, as I've been learning Win2D, and I'm still learning Win2D. So anyway, let's get this out of the way. What we did in the last video, where we left off at, is that we had to basically generate a workflow such that we can allocate resources, resources pertaining towards sprites. Later down the line, it could even be like audio data and stuff like that. I'm just going to take a sip of my coffee. My throat feels a bit dry. Do excuse me. And where was I? Yes, and so when you boot up your program, assuming you're kind of following this tutorial somewhat one-to-one or something, if we look at the constructor of the main class, if I can find it, what we're doing, we're calling this load function. So this is a little bit new. I basically offloaded the instantiation of these events, the create resources, draw and update events for the canvas animated control in this load functionality. which is called here in the constructor. And that's after we set the core window key down event handler, which is just basically for basically catching keyboard inputs so that we can actually make sense of our scene. We can control our characters and stuff like that. Right. So things are a little bit different what I'm about to go through compared to the last part of the video, and I'm going to explain why. So I was having rendering issues. If you follow from the previous entry of this series, you'll notice that I didn't actually get to render anything on the screen. I was having a strange render issue, and I'm going to explain to you why that is. So when I constructed my draw and update class, and also the load animated resources class, I'm going to hop to the load animated resources now. Hopefully my system is just not too slow today. I do worry about that, but it should be okay. There's a few things going on here. So I'm passing a reference to the main page such that we can access members that pertain to the main page. And I'm storing that in a variable called main page reference over here. I instantiate an asset file path list, so it's a list of string, and this basically holds the file paths of all our graphical sprite information. So it could be, in this case, let's see if I can get it up on the screen. That tab is not the right one. I don't even know what it's going to come up on, so it should be fine. Let's see what's going on. I'll just go here, and I'm going to go to my directory, bin x86 debug apex, I think, assets. So I have a rabbit folder, and in here I have a bunch of sprites, as you can see, from jumping animations to running and idle animations, right? So this is going to be our sprite information stored as a file path. Let's get this off screen now. So what I'm actually doing is that I'm accessing that directory that you just witnessed, app domain, current domain, base directory, which actually refers to the root directory of the working directory of the application, and then I'm concatenating the string assets / rabbit / jump. So if I can see if I can find that, it would be any one of these. So as you can see, jump is here, and then we have our file path. This is the working directory. You can't really see all of it right now, but then if you look here, we have assets, which is here, rabbit is over there, and then jump underscore. And then we use a dynamic algorithm in order to concatenate the index that I put at the end. So at the index of all of those rabbit sprites, there's 0, 1, 2, 3, 4, 5, such and so forth. So the idea is that once we have a list compiled of the sprite file paths, if I scroll down, I have a function that says load bitmap from file path. And so the idea here is that I have a list of list, and I'm going to just quickly try and demonstrate this on the right hand side on my notepad file. Hopefully it'll be quite visible. So imagine you have a list. Let's just say list like this, and you have entries in the list. So you have multiple lists in one list. So this list, the inner list, the nested list, actually comprises of the frames for the sprites. So we have jump underscore 0. We have jump underscore 1, and we have jump underscore 2, such and so forth. Let me do one more. Jump underscore 3, like that. Okay, and because it's a list of lists, we can have multiple lists inside the encompassing collection, like this. So this could be like maybe, I don't know, idle animation 1, 0 to 3. I could have maybe like running animation 0 to 3, as you can see here. Just an example, such and so forth, just to illustrate things. And the way we populate this is that we need a for loop to first populate the outer list. As you can see here, I am actually creating a range of the frame list count, which I actually explicitly state the range, which is actually somewhat of a strange move if you ask me, because we may not know how many frames of animation consist within one sprite sheet. But here, I knew for the sake of for the purpose of demonstration, I'm only dealing with one frame. Hence why I only added one entry into this list. And then so because that's now set as my range, I've added a new entry into the outer sprite path list, sprite file path list that is. And now to populate the inner list, the nested list, I'm basically using the index of the I'm staying within the range of the outer list, and I'm now indexing through the nested list. So I'm doing another loop, and I'm accessing the value of the first entry in this frame list, which happens to be 1. So that's how we know there's only one frame of animation. I really hope that makes sense. So if we have one frame of animation here, as you can see, in our first list, that means we have to pass the outer index, which would be 0 over here, because it's 0 indexed. And then from there, we just simply add the sprite's file path, which we already actually stored up above, as you can see over here. So to some degree, you do have to get your hands dirty and actually hard code the file paths. You can't really escape that unless there's some intuitive way you can do it, maybe like file streaming or serialization. I'm not too sure about that. That possibly could work, maybe. I can actually see that happening. Sit down to see how the implementation might work, if possible. But yeah, so the program knows it's looking for this file path directory. Okay. Let me just scroll back down. And then when that's done, when all of this is done, said and done, then I'm calling this generate resources function. Now here's the thing. It's worth, because I went through this already in the last video, but this is what changed. The canvas bitmap list holds the sprite sheets stored as a bitmap in memory. Make sure, and I didn't show this in the last video, but make sure you store this as a static variable. Because what was happening is when the syntax was quite fine, but except for the fact that it was, I had a functional error in that I was creating an instantiation of two lists, the canvas bitmap list and the sprite file path list. So I'm not 100% sure what was going on, but at some level, what ended up happening was that there was nothing being rendered on the screen, and my only guess, and let's see if I can illustrate this here as well, is when you're dealing with a static object, let's say static object, you cannot really make an instantiation of that object. And so what that means is that when you want to access that object, which is statically declared, you're basically going into that memory location and you're saying access from this memory location, like this, something like this. Let's say this specific memory location. So let's say you had a block of memory like this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like 9 slots or something. This is just for the sake of argument. I'm not saying memory works like this. And you had a slot, let's say slot 4. This is where the object in question would be. This is where the respective object would be, 4. And but every time you deal, on the flip side, every time you deal with instantiation, so let's say, for example, an instance object, what we're actually saying is create an instance of an object. So then what ends up happening, if we have the same block of memory, which is kind of hypothetically represented by these 0 to 9 slots, we could say something like, okay, so we're going to instantiate object in slot 0 for the first one, but then what it allows us to do is to make multiple instantiations. So we might want to say, okay, let's make another instantiation, but it'll be arbitrarily assigned to slot 7, and then maybe another one in slot 8, like that. So we have three different instantiations of our of this how can I say this? So we have multiple instantiations of a variable, right? Now, you might start to see the dilemma here. The fact of the matter is, if you have multiple instantiations of some variable, some object in a high level, and you want to access a particular one of these, unless you specifically target the instance that you want, you're going to have issues because you might target, say, slot 7 when you need slot 0, or you might target slot 8 when you need slot 7. But if you use statically declared objects, that eliminates all of that concern, because all the time you're accessing one particular memory location. In this case, it would be hypothetically 4. So what I kind of gleaned is that why is my syntax correct but my functionality is not? When I basically eliminated instantiations of my canvas bitmap list and my file path list, which I cannot find right now. Actually, this one is not. This one is still an instance, which is fine because I'm passing it straight into this. But I'll show you in a minute where this became an issue. It's actually in another class called the draw class over here. So I made this a static object. It was statically declared. And I'll see if I have time to just like kind of prove this. Hopefully, if I can. It might be a little bit nitty gritty, but I think it might be worth it. So canvas bitmap list, statically declared. And then just make sure that we're accessing the correct memory location. So I might do that towards the end because it's going to take a little bit of time. I don't want us to kind of hang on this topic too long. But yeah, make sure you make your canvas bitmap list, if you're following this tutorial 1-to-1, static. It just helps. So as you can see here, I'll go back down. And so, yeah, and I'm just adding it straight in. So I've already gone through how this block of code works in my previous entry into this series. So what I want to kind of get into is to tell you guys about how to actually render. So I'm going to go to my draw class. And I really wanted to write this as I go, but I've already pre-written some of it, and then we're going to kind of do it live so it makes a lot more sense. This is just kind of the summary. What ended up happening is that in my animated draw, first I'm doing a check. I am doing a check to see if the sprite sheet, and just for reference, animated draw is part of the workflow for Win2D. If you watch the previous entry, you'll see how this comes to be. I'm basically passing resources via the canvas animated control, and every update loop of the draw call, which actually happens to be at a frequency of 60 frames per second. This block of logic fires all the implementation within this animated draw logic fires, and then you can put your render flow in here. Okay, so what I'm doing here, at every cycle of our this animated draw call, I'm checking to see if the sprite sheet is null. Because if it is null, then what we want to do is actually request that the sprite sheet bitmap graphic is retrieved. So what I do, I have this sprite sheet object, which is a list of lists, as you can see, of canvas bitmap, which is the class that you want to use to store your bitmap information. And I'm basically retrieving it from my load animated resources class, as you saw earlier, as I guided you guys through over here. So by the time the draw call fires, this would have been populated with the rabbit sprite, excuse me, stored as a bitmap. So hopefully you can kind of start to see the flow that's going on here. And then once I pass this, and then mind you, I think this is statically declared as well. So it's just to make things consistent. So we have like two static objects basically. And they won't necessarily at all actually point to the same memory location by the nature of the fact that they're static. But the fact of the matter is they are symmetrical, if that makes sense. They're list of canvas bitmaps, so they're somewhat compatible, if that makes sense, at a high level. Okay, so from there, I retrieve the sprite sheet. I'm storing it in global scope because this is a global variable, and then I basically end the functionality. And by this time, sprite sheet will be not null. It will be it will actually be, you know, for lack of a better term, I don't want to say instantiated, but it won't be null. There will be an object there available. So all of this check won't happen. So I don't need to constantly retrieve the canvas bitmap at every draw call. This is somewhat like initialization logic. And then what does repeatedly call is this line here on 57, which is e.drawingSession.drawImage. And I'm simply passing the sprite sheet. As you can see, there's two index references here due to the nature of the list of lists. And I have a bounding rect struct. And the bounding rect struct, what it allows you to do is that you can place your bitmap, the the dimensions of your bitmap can be stored within the dimensions of this player rect over here, this rect struct. And then I'm rendering it. So if I go ahead and just quickly save this, I'm going to run this quickly with debugging, why not? And hopefully we should just see a rabbit rendered on the screen. So I'm going to just do that. I'm going to wait for that to load. There won't be cutaways here. There won't really be editing here due to the fact that it's live. So there's going to be some pauses probably due to the fact that my Visual Studio session is a bit long. So I'm just going to take a sip of my coffee. Excellent. All right. Might be a good time to kind of shamelessly plug my freelance page. I'm running a freelance page on freelancer.com, and yeah, basically I'm a .NET developer experiencing what I do. Have a little look at my portfolio items, see what piques your interest, and if you need a developer, feel free to hire me. So I'm over there, just letting you guys know. Okay, so the session is just about loading up now. Just gonna wait for UWP to load, and then we're gonna get straight into things. So what we're gonna do after this, let's expand this a little bit if I can. Zoom out. Okay, seems to be a bit of an error. Now that's fascinating. I literally rendered this earlier and there wasn't an issue. Haven't changed the code and having issues here, so I'm going to have to rectify that. But first, let me just quickly adjust my television set, as I have a little bit of a situation happening on the screen. Let's just refresh my monitor. It's probably a blank screen right now. If not, it will come back momentarily. Sorry about that, guys. Alright, just had to refresh my screen. Okay, so I think there's an error. Have to just kind of work through that, which is kind of nice because it just means there's more content to do. Okay, so the index was less than the size of the collection. Just gonna wait for my Visual Studio to catch up. It's literally slow. Goodness me, it's all frozen. Not too sure if I'm even online, guys. Am I on? Everything has just kind of stopped. Not too sure if I'm even online, guys, because there seems to be some technical issues with my computer. Okay, stuff is happening. Yeah, we're back. Okay, sorry about that, guys. So we have, let's investigate what's going on here. So apparently I'm out of range of the index. We can see here there's a count of 2 in the sprite sheet, and there's a count of 1 here in the top. And as we can see, there's a canvas bitmap. So I'm trying to figure out why it's not rendering. That's very fascinating, actually. What happened if I hit continue? Will it just work? Yeah, I'm not too sure what happened with that, guys. Sorry about that. But anyway, maybe it was just a bit of the threading. There are threading considerations that we have to take into account. The fact that we are dealing with Win2D, we're dealing with certain threads, UI threads and game logic threads, as you can see in the documentation for Win2D later in your spare time. Just have to sometimes just accommodate for that, or just kind of leave a little bit of leeway for it. So what's going on here is that you can see the rabbit rendered on the screen. Just a simple rabbit sprite. I'm going to cross that out now. And I'm going to just X this one out because that's been achieved. Pass the canvas bitmap list to the draw core, which is what I've just demonstrated. So now we're going to do this. We're going to create a simple animation parser to handle animation. Now this is going to be quite interesting, I think. I'm going to just refer to my notes off screen and we're going to get into the coding, a bit more of the nitty-gritty stuff. Let me see if I can find my logic. I do have a bunch of notes off screen. It just makes my life easier to follow the notes. Okay, let me see what's going on here. Just 1 minute, guys. Just kind of find the relevant code reference. I'll walk through what's going on. Okay. Oops. Overshot. Okay, got my notes up and running. So what I'm gonna do is, the idea here is that since we know we can use the draw image function off the drawing session property, we're gonna create a system whereby we can dynamically allocate the frames that we want to use to animate the sprites, so that we don't have to always hard code the values. We only have to plug in the values into some discrete functionality. So I'm going to go through how to do that. See if I can just make sense of my notes very quickly. Animate sprites, initialize animation. Okay, I know what I'm doing now. So I'm going to make some room here. I could do this as a separate class, but for the sake of simplicity, I'm just going to do it straight up here. So let's have let's leave a line there. And let me say something like this. We need a few indexes. So I'm going to say something like private int animation frame. I'm just going to wait for this to go. Animation frame. Private int animation frame. I'll say animation per frame. Index. Oops. I'll say private int. Frame index lower reference. This is all going to kind of make sense as we go along. And I'm going to make some properties for these fields. So just for the sake of time, I'm going to plug it in. Just going to plug it in like this. Misspelled that. I like to put my properties underneath the constructor. I've already got the notes, so I just copied and pasted it. So I just basically made properties for each field. Where am I? I misspelled that. That's better. Okay, so we have here animation frame, frame index lower reference, and animation per frame. Let's go into making the functionality, and then things should make more sense as we go. Make it public. So public, we want to return a canvas bitmap because we want to actually return the graphic itself that we want to animate per frame. Animate sprites. We're going to need some overloads. So we're going to need a list of canvas bitmap, which I think in this case represents our sprite sheet. So I'll say sprites list. We need to pass the animation per frame. So what this does, it dictates how fast the frames of animation cycle. I'm gonna also say here int frame lower index. I'm gonna plug in frame index upper. Right. So implementation brackets. Okay, so probably best to leave some comments here, as I've already done in my notes. So I have an if statement. What we basically have to do here is a check. So I'm going to try and illustrate this on the right hand side as well. So if we have, say, frames 1, 2, 3, 4, and we want to animate them per frame, so let's say at time equals 0, we want to animate frame 0, time at 1, frame 2, time at 2, frame 3, and time at 3, frame 4. First, we need to do a bit of validation, and we're going to just basically say if the animation frame is greater or equal to the upper index. So this would be the upper index, 0, 1, or should we say, yeah, so this would be 0 index, so it'd be like 0, 1, 2, 3. So this is the upper index. As we are, if we approach the upper index, or we exceed the upper index, then this implementation logic will fire, okay? And we're gonna say animation per frame index is reset to the frame lower index. So what we're essentially doing, we're cycling through, as you can see, like this, boom, we hit number 4, and then we cycle back to frame 1. That's what we're essentially saying here. So I'll make sure that's correct. Animation frame is also refreshed. Frame lower index. And I'm going to return the sprite sheet, which is sprite list. Oh, that's not right. Sprite should be sprites list. And we're going to access the via index the frame that we need, like that. Okay. Now for the second block of implementation, let me see, I got a little bit of an error there. Animation frame, did I not declare that? Animation, I spelled it wrong there. Animation frame. It's better. So for this second implementation, I'm going to just basically say if animation per frame index is less than or equal to animation per frame, should be really using the property there. Have a look there. Animation per frame index. Let's see if I can find this quickly. Okay, so it's the overload itself. Okay. So animation per frame dictates the speed. So as long as we're within the bounds of this this limit, we want to increment a index so that we can keep track of how many cycles dictates the speed of the rendering. Do excuse me. Animation per frame index post incremented by 1, and I'm going to return the sprite sheet once again. Okay, let me see how I'm doing for time. I don't want to keep this more than an hour or so. It's probably going to be a little bit run over. Oh, we're doing alright for time. It's about half an hour. And then I'm going to say else. Oops, don't need that preprocessor directive. Else animation per frame index is assigned to frame lower index. So this is another refresh routine. we're going to increment animation frame by 1, and we're going to say return spriteless animation frame, current frame of animation. So I do appreciate all this kind of doesn't make sense properly because it's very hypothetical how I'm going through this. But as we run the program, we're going to iron out any inconsistencies with the code until it makes sense. So now we have this animate sprites functionality. I'm going to just check my notes very quickly. See how I do this. Draw. Make sure I'm doing this correctly. Sorry guys, just bear with me. Alright, sweet. So the idea here is that what we gotta do is pass this logic into the draw image functionality. Now in the first overload, it expects a canvas, let me see if I can get it right. A canvas bitmap object, it might be hard to read, but canvas bitmap over here. I'm actually going to do, yeah, that's fine. I'm going to pass the animate sprites function, which actually returns a canvas bitmap object, and we're going to fill out the overloads. So the first one is the sprite list in question. So it's not a list of lists here because it's going to assume the inner list is specified. That's why it's just a list of canvas bitmaps. So what we got to do is say sprite sheet. I'm going to reference the inner index, the outer index, and the inner index as such, like that. And then what's next? Animations per frame, which dictates the speed of animation. I'm going to say 4. Lower index is 0 because there's only one frame, the bunny graphic, and the upper index is 0 as well because there's only one frame. And we're going to target the bounding rec. Let me see if I've got this right. Maybe it should just be the first one. Yeah, that makes sense. Because in the outer list, we are basically saying this. Not each frame within the list, but this itself. Okay, so this is a bit of a shot in the dark, but I'm going to just run the program. If it works, we should still see the bunny, but I'm not 100% sure. I need to test it and find out. The logic seems sound, but there's only one way to find out. So I'm going to hit start. Any glitches, we can just see what we can do. Awesome. So UWP is loading up. Nice cold coffee light. Excellent stuff. So we still have the rabbit, as you can see. I'm really glad about that. So that just proves to us that the animation routine is functioning just as expected. We're passing the sprite sheet through the animate sprites routine, and all the logic is taking care of the rendering, which just means if we have a larger sprite sheet with more frames, we just have to fill out the overloads, and it will actually render the image moving around. Like there will actually be animation. The notifications, and it's all good. Okay, so I'm going to cross this one off the list. Render the canvas bitmap. We've kind of done that already. Make the scene interactive by adding simple controls. Okay. Create a simple scene. Now this one's definitely going to be for the next entry because that's going to take a little bit of time. In terms of the controls, yeah, I think I can clutch that out right now. We have time. Let me just stop the program. Let me see. Where would I put the control input parser if I have it already? I don't know if I've created the input parser. I have, so it's under controllers. So I'm gonna look at my notes. I would consider using the update. For this, instead of the draw logic. So what I'm gonna do, if I look at my input parser, it might not go amiss to have a kind of a state machine that tells us what's being clicked. So this parse key input returns, well, it doesn't return anything right now, but if we look at this, what we're basically saying is if the key is W, so if we get W, I'm going to actually change that to D, as if we're moving to the right, then I want to return the key that's been pressed, which is D. I'm going to look at where this is being, oh snap, okay. I don't know why that's void, I shouldn't make that void. Oh, I know why I did that, because I have this in global scope. I don't have this in global scope, sorry guys, made a mistake. So, virtual key, just going to change the return type to virtual key. Because if I return the D key, and I look at where this is being referenced, it just means that, okay, every time the core window is being invoked, this core window underscore key down event, or function rather, which is hooked to an event, I'm returning a key input. And so the idea is to have this in a scope that the draw core can see, and then we can take an action based on that. So this, let me see, do I have any global keys? I don't think so. So I'm going to say here, and again, this is not the best approach, I would say, but for the sake of time, that I'm doing it this way. Public and virtual key, I'll say pressed key. And then I'll assign the value of press key to I'll assign the value of press key to the return value of parse key input. This is in global scope now, so every time we go to the draw call, didn't even need to use update actually. We could say something simple, so, and we can still use the update call, but again, I don't want to over engineer this for the time being. We can kind of say something along the lines of, okay, have some validation here. Now, do I have a reference to the main page? I think I do. Yeah, I have one here. Main page reference, because now I can access, unless I statically store. If I statically store the input state, that might work as well actually, but we're not going to do that right now. We're going to use the reference. So if main page reference, let's see if this works, pressed key is equal to virtual key D, let's just say it like that. And I'm going to leave a little comment. I'll say move the player to the right. Then all we're going to do, keep things very simple here. This is a very simple tutorial. I'm going to go ahead, I'm going to look at this player rect. So remember, the player rect is a rect struct that contains the bounds, the dimensions and the bounds of our graphic. So if we were to modify the x-axis, then we are basically moving the player forward or back, up or forward or back if it's the x-axis, of course. So the way I'm going to do this, I'm going to, and I don't think this is the best way, but it's one way that I found. You could reconstruct your rect on every frame. There must be a better way to do this, because what I find, I don't know, I could be incorrect, but if I can access this, I can post increment it by say 8. I have an error, cannot convert from double to numeric vector 2. Let's see what we can do about this. So if I say something like, okay, let me do what I know will work, and then we'll think about how to improve it afterwards. I'll say something like equals new rect struct, and I'll just add the arguments inside. So x with increment, So where am I putting the values of this? Okay, so if I say when I create this rect, I can say x is equal to, I don't know, 40 player rect dot y is equal to, let's say, 100. And if I'm not mistaken, if you increment along the y-axis, you're actually going down. And of course, if you increment on the x-axis, you're going to the right, which is a little bit contrary to the Cartesian coordinate system, where if you increment in the y-axis, you go up. But in this case, I think you go down with Win2D. I'm not 100% sure now. I have to verify that. Okay, so I got my dimensions here in hard-coded in global scope, which is quite handy actually, because now what that means is that I can post increment. I can say something along the lines of player rect. Oh, actually, I need to store them as values, so I'm going to say something like x-axis post increment by 8. And I'll say y-axis as well. So I'll say x-axis, store as a double. And then I'll store as a double the y-axis. Such. Don't really need this too much. Sure why I can't see that. Let me have a look. It's assigned but never used. Let me try and see what's going on. New rect x-axis. Oh, that's really strange. Let me just try and do that all over again. Player rect equals new rect. Oh, that's fast. That's fascinating. Why can't I see it? It's in global scope. Where did I write that? Oh, sorry guys, I made a mistake. That's in the constructor. I thought I was in field scope. So do that here. That's better. X-axis like this. Post increment by 8. Y-axis will stay the same. And then width, I think I have a variable for the width, I'm not sure. Height. $120. So I'll put this in global scope, so width equals 120. Height equals 120. Like such, and I'll just do like this. Height. There we go, it's gone through. So hopefully this should go through. Because what we're essentially doing is the same logic as before. I'm going to comment this one out actually, because we're not using it right now. I'm rendering the rabbit, but this time we're changing some values. The x-axis is post incrementing by 8. I'm going to go ahead and run this, see what happens. And I might end the stream here, because to create a whole scene is something I want to take my time with actually. Just wait for UWP to load. I've got some errors. code path return a value. It'd be if this doesn't return, if this doesn't go through, then obviously this is not going to return a value, because this might fall through. So I'll just do like this. I actually return null for now. Or I can just return a key that's not really going to be processed by in any. So that escape. Because I'm not going to evaluate this button, so I can just use this as a placeholder, escape, and this should now work. And hopefully if this runs, then yeah, because then using this concept, I can then animate frames to make the bunny rabbit actually like move around like an idle animation or jumping animation. But for now, we're just using it to move the bunny sprite across the screen. So it's going to take a minute just to load. UWP just firing up now. Okay, I'm going to see what's going on. Hopefully I haven't broken anything. It looks like I broke something. Let's see what's going on. Oh, I get it. Because it's because this isn't evaluating for D. So I'm not rendering anything because I actually commented this line out. So I'm going to get rid of that. Still need it. I'm going to comment that back. I'm going to resume the debug session. We should hopefully see a bunny rabbit. But the issue is that I hard coded. Actually, no, it should be fine. So if I hit D, it looks like we have an error. So input parser was null. Looks like I didn't instantiate it. Virtual key is D. Input parser is null. So if I go ahead, see, I guess I could instantiate it here. Restart the program. I didn't make an instantiation of an instance variable. I'll just wait for UWP to load up. Okay. Right, so we have another issue here. This is a timing issue, I believe, because of threading considerations. I'm gonna try catch everything. Such. Oh. Let's give it that. Such. And then this should hopefully run through until everything is loaded. See what happens. That's interesting. I hope the computer just runs with me. Okay, I'll stop the program and I'll restart. Okay, I'm going to start again in debug mode. How am I doing for time? Just under an hour. Not bad. If I got an error. This compile XAML error. It's a bit weird. Okay, not all code paths return a value. So I'm returning canvas bitmap, and because I'm not returning here. Return now. Like such. And I think I need to have a return statement here just in case. So that means that all the code paths return a value now. This is unreachable, so I don't need it. Okay, and then hopefully we should have the correct functionality in place for this application. Okay, let me see what's going on. Value doesn't fall within the expected range. That's a new one. Oh, that's very strange. Oh, that's very strange. I've never seen this one. Let's try and catch this exception, see what happens. There's some new exceptions here. Let me try this. Is that a threading situation? No idea. Very strange. There we go. So we have the rabbit. I think it was just threading. What happens if I hit D? And the rabbit's moving. There we go. So guys, that's in a nutshell. It took a while to get there for such simple functionality, but such is the nature of code. Alright, so let me just make the bunny go off screen so you can see it. There you go. So let's run through what I did. So I took you guys through the idea behind statically storing your sprite sheet, and then we looked at creating an animation parser to handle animations, and I just made bog standard controls to control the scene to some degree. So of course this is all condensed within 1 hour, and you got to kind of extrapolate these concepts to make a full-on game, if that makes sense. But hopefully these fundamentals help you to see a little bit of an approach in how you can utilize C# in your own scenario in order to create a gaming experience. In this particular case, I'm using the Win2D graphics library provided by Microsoft. Thanks guys for tuning in. I'm gonna sign out, and I bid you all a great day. Thanks for catching this stream. Bye bye. Hope you found it helpful.